Science in pajamas, woo! Alright guys, today we're going to continue talking about velocity, but we're going to talk about how you can use velocity, the velocity equation, to solve for, either the displacement of an object or the time it took to move that displacement. Now, as we remember, let's say we had a car. And the car was moving along, and it moved 100 meters and it took it about 20 seconds to move that far. Go through, we plug it in, and we have equals the distance it was moved, 100 meters, over the time it took to move it, which is 20 seconds. We go through, we solve it, and when we divide the two, we get 5 meters per second. So it's not really chugging along at a very fast rate. So that's how we solve it for velocity. But what if we needed to know how far it moved? Maybe we know that the velocity it was moving at was 43 meters per second, and it moved out in it traveled for 10 seconds. Well, what then? What we can do is we can rearrange this equation. So we can have, it's delta v equals delta x, delta t. Now, I know what the time is. Time is 10 seconds. I know the velocity. Velocity is 43 meters per second. But what about the distance? How far did it move? Well, we gotta rearrange this equation to solve for that. So what I'm going to do is I want to get time out of the bottom because I don't want a fraction. We multiply both sides by time. That'll cancel it out on that side. And then I'm left with delta v times delta t equals delta x. And now that's oh, I know how to do this. Block the light with my body. There we go. Alright. Then what we can do now to get, actually no, we are already done. Sorry. But yeah, so all we gotta do is multiply the two. So we have delta x, so the displacement equals the velocity times the time, which would then be 43 meters per second times 10 seconds, and our displacement would be 430 meters. So that is how we solve for the displacement. All right. what if? Now, what if you knew that the velocity was 50 meters per second? And I know that it traveled for 200 meters. I want to find out how long that took. Now the way we can do that is once again using our same equation but rearranging it. We have delta V equals delta X over delta T. I want to get T by itself, but I also do not want it so that it's on the bottom of a fraction. So once again, we are going to multiply both sides by T. This will get it out from the fraction, so it's no longer a denominator. That'll cancel out, and we are left with delta V times delta T equals delta X. There we go. All right. Well, again, we want to get T by itself. So I'm going to divide both sides by delta V. So it's going to cancel out on that side, and we are left with delta T equals delta X over delta V, which would be X is 200 meters divided by the velocity, which is 50 meters per second. And when we go through that, 200 divided by 50 will give us 4 seconds. Now, something else that's nice for these kinds of equations, it really only works if it's in this kind here, is what I like to call the triangle or pyramid. X is on the top of T. And then we have delta V. Now the reason why I like this so much is because it actually tells you what to do to solve for each value. So if I want to solve for the velocity, it is displacement divided by time. If I want to solve for time, it's displacement divided by velocity. And if I want to solve for displacement, it would be velocity times delta T times time. That's kind of why I like that method too. Alright, but I hope this kind of helps you out, and we'll see you next time. Alright, take care, you guys.